Well, we're back at it. Got quite a bit going on here. I'm going to try to get this all in one vid. This is the new and, quote, improved Magamp. Same as before, we're using the capacitance to trigger the ringing in the toroid core, and I'll show you in a second. Capacitors in series. I've got a neon bulb right across the output of those two caps. And then the two regular 10-to-1 transformers are in the center here. They're wound backwards. If you could make that out, they go to the center, and then I loop the outside, and then the same with the output side of those, which would be the 12 volt side. This is the 120 volt side. That's the 12 volt side. And I drew that backwards. That's actually 10-to-1. Anyway, and then just like normal, where we have I have the second toroid back in here now on the opposite side. So I pretty much try to duplicate the same setup on both sides. I have another matching transformer here that's the same as these two transformers, and it's hooked. Oh shoot, what is it? This is the 120 side, and that's the 12 volt side. And my frequency source that I'm putting into it is 243 hertz. Now, I'll show you that in a second. But so here's the setup. Main power coming in from the Variac. It's on around 90 volts. This is the first primary toroid that has the ringing, triggered by the capacitor in series. The two capacitors out here. Here's the neon in parallel. Get a quick shot of the neon up front. One side's lit up, so there's just some line noise coming through. That's you see on here. So I'm tapping both. The other side of each of these capacitors. This is where the meter probes are, that's where the voltmeter is, and that's where the neon bulb is. So all three systems of measurement are there, and at idle, I'll say, we see about 52 volts, which is pretty good, as this 12 volt, or this yellow winding is supposed to be 44 with 120 in, and I'm only putting about 90 in. So we're seeing a little more than supposed to, but that's because of everything else. So anyway, this is the other toroid, same exact opposite side, coming out of the 12 volt side here in the same configuration as we were going in, and then the outer two are looped here. This yellow or white wire here is the same wire. And then through the transformer, we have the other side of the transformer, which has the 220 volt cores in series. There's a capacitor in the center. So if we were to hook the two together, you know, as if you would center tap it, but I've split them across the capacitor. And my 12-inch 8-ohm speaker, or 10-inch 8-ohm speaker, is hooked to that capacitor. I forgot to draw that. And then anyway, the outer two leads are the input frequency source. So this here is the custom-made 50-watt push-pull amplifier, rectifier tube, two EL34s acting as pentodes, 12 AX7, one half acting as a preamp, the other half acting as a phase inverter. And as we saw in the other pictures, it produces a real nice square wave on here when it's running. So first thing I'll show you is when we kickstart it. Now you see there's the nice inverted square wave. The one side is a little bit lower than the other. These are both on 10 volt scale. So I get a little bit higher voltage on one side versus the other. Neon bulbs lit up nice and bright. We're reading almost 120 volts AC coming out of the other side of that capacitor. Let's see what we got here. So this is the stage. This is the first stage of vibration stage, we'll say, to where we get almost 3 times the voltage on the other side of that from the ringing that's going on. This transformer here is not really ringing, it's just kind of hanging out there. We have another state where now we can trigger phase 2, and I'm going to do that with my phase 2 triggering tool, and I'm just going to short half of this core on this one transformer, and you'll see what happens. If I can get the reaction to start. This one's a little picky. You see my voltage start. So now we've got a bit of a shake of a weird, you know, LFO kind of fluctuation going on. If we turn it way down, you can see it happening there. What's really interesting is that you can see the LFO affecting in the neon bulb. So we literally see the push-pull going on right here. So before I do that, it's being picky. Every once in a while, I'll get it to ring, and you see the voltage jumps all the way up to 330 volts. It's a little picky. This was working fine a minute ago. Where was that at? So there's one there. There's a harmonic there that gets us to 180. If I... That shuts it off. Well, that's not the cool part I was going to show you anyway. At some point in time, I can get this one to start ringing too, and you'll see that the voltage would have went up to 330 volts on this side of the mag ball, on this side. Okay, over here, there's no change in voltage when that ringing starts to happen. I don't know why it ain't working right now. I turned the voltage down a little bit. That was the reason. Right. Alright, anyway. We'll go back up to 90. While it's off, you see there was a little bit of fluctuation in there. Can't really get that to focus on the neon very good. But anyway, I'll go back out. Alright. So we're back at rest state, at idle. And what we're going to do is we're going to pump 200, focus, 243 hertz at 200 millivolt amplitude into the input of the audio amp, and the 8 ohm tap off of this output transformer. What's going on, phone? Let me clean that. Of the output transformer is going to this. This is the matching transformer. So here we have the 12 volt side. So 8 ohm tap here, going to the 12 volt side, 120 side coming out, going to the 120 or the outer 240 taps on this, with the speaker and the cap in the center. So what we'll see is some really peculiar LFO operation going on when the wave starts happening. So without, in the idle state, we'll turn on the amplifier, and you can start to hear the 243 hertz coming out of here. And when we look real close at, because there's a 60 hertz hum also occurring here, we get a standing wave occurring. It will focus. There we go. Beautiful. And that's the speed of that oscillation is directly controlled by the LFO. So let me go back down to, oh, not that. I'll go back to 240. Sorry. And you'll see as once it settles, there's no fluctuation. But if I go to 241, we see it start to happen. I don't know why this won't focus any better. But you see the sides start dipping out. Now see, the one side is stronger, it's always lit. I'll go up to 243, and you see it's a little faster, so it's easier to detect. This thing don't want to focus right. But you can see what's occurring on the neon electrodes right there. And you see on our signal, you can see the ripple in the 60 hertz hum on there. So let's kill that for a minute. And now we'll kick it in. You see we got our square wave back. Neon's on full. There's no fluctuations going on there. We're back to 120 volts. Now I'm going to kick on the amplifier. And you hear 120 hertz hum come out of here. And then as the filter caps charge up, you start to hear the tubes bleed in the 243 hertz. And there's just a slight disharmonic out of tune, and that's visible in the waveform here. And then you can see as I back it down, I go down to 240. Here's 240. You get no fluctuation. 241, you just start to see it, what appears to be traveling in reverse. If I go down to 239, the LFO goes forward. So it's an LFO tremolo kind of circuit. No fluctuation in the neon that's detectable anyway when this is happening. I got to turn that off because this gets pretty hot. This is a non-standard, a standard output transformer being piped into a non-standard matching transformer. This is not 8 ohms here, so I got to be careful. I'm really overdriving those tubes until I get it wired better. But let me kick the state back off. So now we turn it back off, and you see. Well, let me see if I can get this here. So now we're on, and now I'm going to turn it off. And look at that. There's still a ring down that happens. Let me do it again. On. I shut it off. We still see a bit of a. There's like a return to unity kind of fluctuation that still goes on this way, or at least this way, back and forth, until it settles. So there's a settle period that it has to go through. Whoops. Let's turn that back on, and there's our. This is kind of like a, I don't know, somewhere in between the 120 volt ringing and what I was getting the 330, but I can get 180 if I strictly short that. And I can't really start it any other way except kicking that coil. No real change in output by removing these caps in the circuit, obviously. But oh well. You can see it once you get up there, but oh, sorry. That's the weirdest part when it does that. It's like amplitude modulated tremolo. And if I go back, well, if I turn the amp on now when it's doing that, you can just start to hear the 234 come through, or 243, I mean. Yeah, oh well. Can't get it to happen. I'll see if I can get it next time. Pretty neat, huh? That neon bulb allows us to look at what's going on there. And we can see that it directly opposing what is just a hair above quarter wave length counter frequency here is causing a standing wave to manifest in these two cores here and the surrounding capacitor circuit. And that's why we see a massive voltage increase here that's not really indicative of the input voltage, because we're stepping down. I'm going to be unhooking this and trying to hook one of these toroids, or at least the input through the capacitors, directly to the anodes on the tubes. And I realize that'll be like a half ohm load for those anodes, so they're supposed to expect around 3,500 to 4,500 ohms of impedance on the primary side that the anode supply. So I'm going to have to change out my cathode resistors and try to compensate for that amount of resistance or impedance that's happening here. That way I don't draw too much anode current and burn out who knows what inside of there. But I think that will allow me to drive non-standard transformers. All we have to do is really just match the cathode resistor to accommodate for the same amount of 25 milliamps per tube, I believe is what the spec calls for a 60% utilization. Neat, huh?